Pick Computer Science video number 28, where we look at the role of decisions in computational thinking. Now, we all have to make decisions, and many of them every single day. For example, should we go out tonight? There might only be two possible options for that. But if we decide yes, then where do we go? There might be several options for that decision. And computers have to make lots of decisions as well. So here on the right hand side we've got a flowchart depicting an algorithm that might be in place for system security, so a computer login, for example. So user inputs password and clicks log on, and then we come to this diamond shape, which in a flowchart means a decision. Does password equal Apple? If the answer is yes, output a success message and load their desktop. If the answer is no, we output an error message and start again. And there'll be many other examples of when we as humans need to make decisions, and therefore our abstract version of real life, computer programs, also need to make decisions. When we think of decisions in terms of computational thinking, we might use lots of other words surrounding it, such as logical conditions, program flow, branching, and preconditions, and we'll talk a bit about what each of these means now. A logical condition is just another term for a decision, and here with our diamond shape, our logical condition, we can think about how this will be implemented in some program code, and it can be implemented using something called selection, which we'll talk a bit more about in a future video. But your selection might look something like this in code. If password equals Apple, then output success, else output error, end if. Logical conditions can also form part of what we call iteration, or as we might already know it, looping. So an example that might befit our diagram on the right a bit closer could be this: while not password equals Apple, output error, end while. And those first three lines of code would repeat until password does equal Apple, and then we can output success. So logical conditions are used in both selection and iteration. The term program flow is quite a simple concept to grasp. It's just the idea that a program can go in more than one direction because of decisions, because of conditions, and this example here helps to show that. Branching is a term that can also be used for decisions, for selection, etc. If we look at the Wikipedia entry here, it'll give us a bit more insight into exactly what branching means, but it generally means a sort of low-level programming construct. And when we say low-level, we mean programming code that is closer to the design of the processor than a high-level programming language such as VB.NET or JavaScript. And it's a construct within low-level programming that allows for decisions to be made, and those decisions might form part of selection or, again, iteration. But we'll do more on branching a bit further down the line in this course. I also mentioned the term precondition earlier. If we look up a dictionary definition of precondition, we might see that it's a condition that must be fulfilled before other things can happen or be done. So the sort of thing we might expect, and that's the noun version of it. It can be used as a verb as well. So you might precondition your hair, but we're more interested in the noun definition. And a precondition is very much linked to decision making and selection, in that you might want your program to do various things, but there's going to be a condition in there that has to be abided by before the flow of the program can continue. So the example here is that this program, that's written in a programming language called Eiffel, requires that the a_hour variable lies between 0 and 23. So that's a precondition for anything else in the program, so the do and the rest of it to happen. So a precondition, I guess, is a type of condition that we might use. So really, in order to sum up this video, we just need to try to remember all of these terms when it comes to decisions in computational thinking. And in the next video, we'll have a look at how to actually start to code some decisions in a high-level language. But thank you for watching this one.